Hello students, today we will understand what is a normal force, right? And this is a very important concept and we need to understand it, and as I said, we'll understand it clearly, very clearly, right? Okay, so let's imagine a block of ice, and I'm going to imagine it as resting on a frozen lake. Okay, so that means ice on ice, right? So it's a frozen lake, and on that frozen lake I'm imagining block of ice. There is a reason why we imagine ice. So this is the frozen lake, and I'm imagining another block of ice as well. So this block of ice is stationary and this block of ice is moving, and it's moving at a constant velocity of 5 meters per second. Let's say it's moving, and this block is stationary. So as I said, this is ice, this is ice, and this is also ice. And the reason why I'm choosing ice over ice is that I want to get rid of frictional force. So we can assume friction to be zero, friction between the surfaces that is making contact. So at this point I can assume it to be zero when I'm considering ice sliding on ice, right? That's the reason, that's the only reason why, because we'll bring in friction later. Okay, so you have this ice, it will have certain weight. Okay, so let's say its mass is 10 kg. Its mass is 10 kg. Now, always we are going to, in this video, you need to always remember that the relationship that we are invoking comes from Newton's second law, and that is sigma F is equal to 0. Sigma F is F net force. So I'm so sorry, very sorry. Sigma F is equal to mass into acceleration. That's what I meant, right? Sigma F is equal to mass into acceleration, or F net. Sigma F is F net. F net is equal to mass into acceleration. So this is what we are always invoking when we are dealing all the cases, these two and the cases hereafter that will follow. Okay, so this is stationary, meaning what? It has got zero velocity. It has got zero velocity. So if we invoke second law, Newton's second law, sigma F is equal to mass into acceleration. Velocity is zero, that means it's constant velocity but zero, that means acceleration is zero, which means net force, right? Net force. So we are saying F net is equal to sigma F is nothing but F net is equal to mass into acceleration. If velocity is zero, that means a constant velocity having zero value, magnitude. So F net is zero, right? F net is zero. Fine. So if F net is zero, now, so the body has got zero net force. The body has got weight, right? It has got certain mass. So that would be, that is acting downward. The weight of the body, which is equal to m into g, the gravitational acceleration is m into g, so that's acting downwards, right? So the weight of the body is acting downward, right? Acting downward. Now if the weight of the body, which is equal to m into g, is acting downward, and we are saying that net force has to be zero, and this is vertical downward force, it means that there has to be an upward force which cancels out this mg, right? Which cancels out this mg. So the upward force here is normal force, Fm, and that also has to be mg. That also has to be mg, otherwise this will not be cancelled. Now why this normal force exactly, you can understand this normal force also getting it at taking a microscopic view, how these bodies pressing and there are molecules, how they are resisting the negatively charged particles, pushing up negatively charged particles. We can, that's a microscopic understanding, but we don't have to get into that. We are interested in the macroscopic effect. The macroscopic effect is a normal force, and the normal force has to be exactly equal to mg, right? So this is one understanding. We are going to add more complications to this. Now let's consider this body. This body is moving at a constant velocity, right? Now when it is moving at a constant velocity, what will be the net force on it? What will be the net force on it? Obviously the net force is zero, because the body which is moving at constant velocity will have acceleration equal to zero, so net force has to be zero, right? Net force has to be zero. So it means it's moving in this direction, so net force in this direction is zero, right? And so in the sense that there is no friction, because I am considering ice over ice, so the body is moving, there is no force acting on it in horizontal direction. It is moving at constant velocity. There is no resistance. Of course there will be if you are neglecting air resistance. So that's horizontal. What about vertical? Again, the body has got mass, right? Consider 10 kg of mass. Mass is equal to 10 kg, right? And the weight of this body acting downwards is m into g, that is 10 into 9.8, which is equal to 98 newtons. Same was here, 98 newtons, because I considered mass, okay? So that is acting downward, and then we are saying that, see, imagine if there were no force acting upward cancelling this, what would have happened? The body would have accelerated in downward direction. Same here, I should have mentioned it. If there were no force acting upward, the body would pierce through the ice, accelerate through the ice, right? It's not happening. That means there is a balancing force, and that is normal force. So here also body is moving, but body is not falling down because of its weight. So what is holding it at that position? It is the normal force, right? Normal force, Fm, and that also has to be equal to mg, okay? That has to be equal to mg. Now we are going to add something more to this. So this is our understanding of normal force. But now what if the body, this body, I am considering the case body is stationary, body is moving horizontally, right? Now we will consider case, what if the body is moving up and down, right? And we can consider the body moving up at constant velocity, right? Or we can say body is moving, accelerating, or we can say the body is moving down, right? And accelerating downward. So we can consider all these cases. And will the normal force change, or will it remain same? And that's what we are going to consider. But in order to consider that, it's easy. We could have said that body is moving up, like in the air. But instead of that, it will be easy, and that's also becomes experiential thing if you imagine that a case of a person traveling in lift, right? And the lift is moving at constant velocity, accelerating, decelerating. For example, when you get into lift, you're stationary, and then the lift starts, it's accelerating up to a certain point. Suppose you want to reach some 20th floor, so it will accelerate, then it will have constant velocity, then it will decelerate, right? When you are nearing the floor on which you are going to descend out from the lift. So let's consider these cases. So let's say this is a lift, right? And I'm imagining a person standing in the lift, okay? I could just see that. Okay, so in this case we will imagine that acceleration due to gravity is g, that is 9.8, but we will, for the sake of simplicity of calculation, because otherwise I have to use calculator, or I just want to keep it simple. I'll say G is 10, right? 10 meters per second square. We will consider always as 9.8, but for here, just to make calculation simple for me, right? So I'm saying it is 10 meters per second square, 10 meters per second square. Okay, so here the person, let's assume that this is stationary, the lift is stationary. So this is V equal to 0, okay? And I'll show a string to which, metal rope to which, so it is V, you can immediately say that the velocity of the lift means velocity of this person, right? Because the person is standing on the floor of the lift. Okay, so let's say that the person weighs the 10 kg, that means its mass is 10 kg, okay? The mass is 10 kg. Now, so what will be the normal force, right? What will be the normal force? You can immediately say this is stationary, so F net is equal to mass into acceleration. Acceleration is 0, so F net is 0. So there should be, net force should be 0. This person is standing, the weight of that person should act downwards on the floor, right? What would be the weight? 10 into 10, right? 10 in mg, mg is 10 into 10. So the weight acting downwards is 10 into 10. Obviously that has to be balanced, and the balancing will come from the floor, right? If there is no upward force, the person will pierce through the floor, right, and accelerate downward with acceleration equal to g, right? That's not happening. That means the person is not falling down, piercing through the floor, so which means there is an upward force, that is Fn. Fn is also 10 into 10, okay? That is when the lift is at constant velocity, is at 0 velocity, it is stationary, right? Okay, now let's consider lift, okay, same person, of the same weight, so same mass, again 10 kg,